Okay, so today's topic is also, really it's just information. I don't like the initial topics because it's more or less I'm just talking at you about stuff, and there's really not a lot for us to do yet. We're going to get there, but it's really just info that you probably knew. Today we're going to talk about safety and WHMIS symbols. And you guys will eventually write your PAT. You guys have heard about this a little bit, right? Grade 9s, we write PATs. There is always, always, always a question on WHMIS symbols. So it's one of these things where I need to kind of just show you what they are, and you just need to like memorize the WHMIS symbols and the different categories of safety. Okay. My intro slide basically just reminds you that, look, chemistry is supposed to be a hands-on science. I want to do chemistry. We're going to go and trade labs with Janae next week, actually, and I'm going to show you a bunch of cool chemical reactions, some of which we actually have to do in a fume hood. Do you guys know what a fume hood is? It's basically like it's called a fume hood. I'll show you when we get to the lab. I can't even describe it here, but it's basically like, I think this right here in the diagram is a fume hood. It's basically like a big container where you lift up the lid, the glass lid. You do the work inside and then you close the lid behind it so that if it explodes, you're like protected. That makes sense? So, and I've got a couple of pretty cool labs we're going to do where it makes a bit of a bang. Okay. So I just want to remind you guys though that like, we do need to make sure that we're being safe whenever we're in the lab. That is an important consideration. But this is kind of an oddball topic. It really is just, I'm going to tell you some safety words, and again, just memorize them. Okay. So the first thing I need you guys to know about are what are called the safety hazard symbols. And these should be on basically any commercial product, any household product that has any danger to it at all. Right? Say you go to your house and you look underneath the sink and you find some bleach, or you find some Lysol, or, I don't know, ammonia, I don't know, any sort of cleaner, right? You should hopefully recognize some of these symbols. Like, I gotta be honest, my 6-year-old, I feel fairly comfortable. My 6-year-old can probably look at the pictures and like, make a general idea of what's going on. Because that's the whole point, right? It's meant to be universal. Anybody in the world, even if you don't speak English, should be able to look at the picture and figure out the basics behind it, right? You guys have seen these before, haven't you? Flammable, toxic, explosive, corrosive, right? The hand that's dissolving, right? They're meant to be pictograms. You guys know that word? Pictogram? Basically, it's a symbol that has like a picture in it. Road signs are another example of a pictogram, right? Where, you ever seen the one where it's like a sign that looks like this? There's a picture of a car, and it like goes like a little skid mark. There's a car from behind. And that's supposed to like indicate to people that it's like, it's icy. You could slide around ahead. Same kind of idea. Kale.
Does it, so the octagon means, if it has an octagon around it, it means it's like the most dangerous in Earth.
Yep.
The triangle means the most dangerous?
Nope, you were right the first time. The octagon. Ah, you guys have heard this before. Okay, yeah, the more sides it has, the more dangerous it is. So octagons are the most dangerous. They're red. Stop, basically, right? Like a stop sign and a stoplight are red. Those are the most dangerous. The yellow or the orange diamond, they have 4 sides. That's a little less dangerous, but still be careful. These ones are known as cautions. They're like yield signs. They're like, like when you're driving a yield sign. Doesn't really mean stop, but it means kind of stop. Right? I actually have it written on the next slide. So if you do have the notes printed off, it's on the next slide. If not, here it is. In terms of danger, and you need to memorize this. So like just write this down. And just like before the test, just look it over, memorize it. Yellow triangle, caution. More dangerous than that, an orange diamond, a warning, and a red octagon, dangerous. There you go. We don't actually have a hexagon on these ones. At least there's not supposed to be. So, but it sounds like you guys have heard this before somewhere, because that didn't seem like it was new. Okay, cool. So. 3 sides versus 4 sides. I don't know that I can draw a really good octagon. Versus 8 sides, or however many sides I drew there. So that's the symbol, that's the shape. But we still have to talk about the symbols that go inside. And again, those pictograms, I just need you to memorize this. I guarantee you this is on the PAT. It's 1 question out of 55 they're going to give you. It's a really easy one. You just need to know your symbols. Okay? And as long as you've got some decent common sense and a little bit of memory, you'll do fine. So I know some of you guys are writing these down by hand here, so I'm going to flip the slide. Is that okay? Print the notes off beforehand, guys. Makes it a lot easier. So here are the 8. Actually, I lied. This is an old slide. There used to be 8 symbols. This is now changed. I had to update my notes this year. There are now 9. They've actually updated WHMIS in the year 2015. Okay. And, well, I've been teaching for a little while. And so in the year 2015, they decided to revamp the whole system and make it a little bit easier to follow. So it used to be 8 symbols. Now there's 9. I've got pictures of them in the future slides. And we're going to need to know the new symbols going forward. So I'll show you what the old symbols were and then what they've changed to. So here's the old symbols. Maybe you've seen these before. This would be why I'd suggest print the notes off in advance, because like I don't know how well you're going to be at drawing these. So so go print them off. Print off my notes in advance. Here they are. Let's talk about them a little bit here. This is a compressed gas. We have to be careful about compressed gases because if they ever like have a leak in them, it can like it can spray you, and depending on what it is or how much pressure comes out with, it could be quite dangerous. Okay. This is a generic symbol for anything that's dangerously reactive. Okay. There are some compounds that we even have in the back of our chem lab where they're so reactive that they could just be set off by like the littlest thing. Like dynamite might be a good example. It would fall in this category here because it wouldn't take very much, like a dropping it or something like that, and it could go boom. Right? Now, it could be more than one. It could be dangerously reactive and combustible. Okay, it doesn't have to be one or the other. But anything that's like highly reactive, it doesn't take much to set it off, would fall in this category. Okay. I don't expect you guys to know much about oxidizing yet because we'll only learn about that in grade 12 chemistry. If you want a better explanation, I'll give you one like maybe like in a small group or one-on-one. But anything that does something called oxidizing has its own category. Okay, oxidizing does not mean that it sets on fire necessarily, though. Okay, I know it looks like this thing is setting on fire. That isn't necessarily what it does. But I'll tell you more later if you care. Okay, everyone's seen the skull and crossbones, right? The classic pirate flag. It means it's poisonous and infectious. The flame, it's flammable and combustible. It can blow up. This one, most people have seen this one before, the little like, I don't know, it's called the biohazard symbol, right? If there's something that's going to be like an airborne toxin, like biohazardous mold, and you have to like drape the building off with like plastic sheets around it because of that. Asbestos or anthrax, if you've heard of those would be biohazardous. Corrosive, here's a symbol for corrosive. Basically, it means that it could like eat away and dissolve and corrode your skin. You got to be careful on those. And then these two are probably one of the biggest reasons why they've updated the system. Because if you look at the old definitions, this was poisonous and infectious, causing immediate and serious toxic effects. The key word being immediate, like they happened almost right away. This is poisonous and infectious, causing other toxic effects. This was like more long term. And that was a bit of a challenge for people to work with because both of these mean it's toxic and poisonous. But like one is like, go call poison control now. And one is, if you keep doing this long term, it will hurt you. Does that make sense? So this is the one where you like call poison control. If my daughter, for example, got into the cabinet and happened to like drink a whole bunch of bleach, I'd be calling poison control right away, right? Whereas this one right here would be like, if you took a little bit today and a little bit more tomorrow and a little bit, and you had like prolonged exposure, eventually the buildup would be a problem. Like arsenic poisoning would be a good example. If I just had a little bit, or mercury poisoning, a little bit every day. You get the difference there? Now ignore this slide, because that was before 2015. And so although you probably know some of those words, I need you guys to actually know the new symbols. And I don't know why it says there's sometimes 9, because there's actually 10. The biohazard one gets like a circle instead. I don't actually fully get why they made that distinction. But there's actually 9, and then this guy's like number 10. So I found some pictures online. Many of them are the same though, hey? Like a compressed gas. We had one of those before. A flammable material. We had one of those before. Oxidizing material. We had one before. But they changed the symbol on one. they changed it to an explosion hazard because that just kind of made more sense. So rather than doing dangerously reactive, they changed the symbol to like it literally looks like a bomb is like blowing up in different directions, and I think more people get that intuitively, right? They changed this one then to harmful or fatal, right? The poison one. They just phrased that differently. We still have corrosive and we still have biohazardous. Those really haven't changed. But this one and this one are some of the new ones. Now we have a health hazard and we have like the harmful one, but like the long-term harmful, not the fatal one like the poisonous one, but like a different one. And this one's also new. If you can't see that, that's a fish, I believe, kind of like on land. This is now harmful to the environment. So there's a couple new ones now. And I believe I've got a slide coming up next that kind of explains them more. So I'm going to find that one here. Here's the 9 plus the 10th one. I don't know why they put it differently. So exploding bomb. Flame for fire hazard. Flame over circle for oxidizing. High pressure gases. Corrosive. So here's what I want to point out. The skull and crossbones is toxic with short exposure to small amounts. Even a little bit could kill you. That's what we're talking about here, right? Whereas this one right here, the health hazard, may cause or is suspected of causing health effects, but like long term. Like these could be things that maybe they cause cancer eventually, right? Like I would expect that maybe this should go on a carton of cigarettes because long term it's bad to your health. But like if you smoke one cigarette, not that I ever say you should, but if you smoked one, are you like going to immediately die? No. But if you smoked like a pack a day every day for 20 years, yeah, you're probably getting lung cancer, right? So that's where this one would come in. This is similar sort of thing there. These may cause less serious health effects or damage, like the ozone layer. I'm actually really not sure what they're going for here. And then here's the environment one. Here's the biohazard one. Long story short, I just need you guys to know the symbols, and basically what you're probably going to get as a question is a matching question. On the PAT, they're probably going to give you like 4 symbols, like 1, 2, 3, 4, and I can't draw nearly well enough, so I'll do my best. And they'll give you like 4 lines here, and they'll say like which one is toxic, which one is environmental, which one is what else is there? There's biohazard. And why don't we go with reactive. And then they'll number these as like 1, 2, 3, and 4. And then, for example, if the biohazard, I can't draw in the slightest. Say this is the biohazard symbol, the one that's the worst. Hang on, let's do this better. I'm bad at this. Where's the biohazard one? Here it is. Add to new page. This is not as effective as I want it to be. Okay. Do you get what I'm going for here, though? Imagine that this was in that box right here. Then you would match it and say the biohazard one is here, and you'd match it. Okay? That's probably what you're going to be asked to do. Okay? I think I'm wasting time, because I hope you get the concept here. Okay? There's not a lot more to it. The last thing we need to talk about today is something called a material safety data sheet. And again, in 2015, to make things a little bit more streamlined, they actually changed these, and now it's called a safety data sheet. So they just took the M off the word. Rather than it being an MSDS, it's now called an SDS. Okay. I think the rationale was they wanted to make it a little less confusing, and they also wanted to make this universal, so that the rules in Canada were the same as the rules in the States, same as the rules in Australia, same as the rules in Europe. Because before this, every nation kind of had their own safety setup, and they wanted to make this a little bit more universal. Does that make sense? So my notes here are about the old safety data sheets, but I just modified it and just said this is the new name. Okay? And all these things do is they kind of tell you for any compound or any element or any mixture, whatever it is, it just tells you some of the health things you need to know, like, is it toxic or not? What do you do for first aid? What do you do if you spill or leak these things? And so like as a teacher working in the chemistry room, we have all these sorts of data sheets listed just in case something goes wrong. And really any workplace should actually be posting these if you're working with a dangerous chemical. So that like if you spill a whole bunch of a cleaning product at your job at 7-Eleven, I don't know, then you know how to clean it up properly. So here's the basics of what it looks like. I found one online. This is for this really, really dangerous chemical, like the most dangerous one you've ever heard of, sodium chloride. No, it's actually not dangerous at all. Sodium chloride is NaCl, and it is basically salt, if you didn't know that, which is so undangerous that like we can put it on our food. Like it's not dangerous at all. Okay, but it is a chemical, right? Because we can eat salt, right? It's not toxic. It's not dangerous. So it's got like all these different sections to it, and like they're long. These things are boring. I would never need you to read one, but I just need you to know that they exist. Like section 1, it's going to identify the chemical. Section 2, it's going to tell you some more composition. Here, can you guys see this one? Section 3, it's going to give some hazards. It's going to tell you if it's dangerous or not. Right? Salt is not dangerous. And so like you could go through this whole thing, and there's like 13 parts to them. It talks about what to do if you spill it. It talks about whether or not it causes cancer. It talks about what to do if it ends up in a lake or a stream. Okay. Here's what I need you guys to know. It's also accompanied by this little diamond system. And it's another way that we use to kind of like quickly look at something and just tell, is it dangerous or is it safe? And you don't even need to know anything. If I told you that this thing had a 1, a 0, and a 0, you probably would think, oh, it's pretty safe. Because like 1 is, well, a small number, and zeros don't even exist, right? I'm going to explain this in a slide, but if you can see, the blue is all about its health effects. Red is all about whether or not it can like be lit on fire. And yellow is whether or not it reacts. Salt is not reactive. It doesn't set on fire. Salt does have some health effects, though. Now, if you eat some salt, Gail, can you stop that? It's distracting here. If you eat some salt, are you going to immediately die of something? Well, no, obviously not, right? But if you had like a large amount of salt over a long period of time, could it cause some cholesterol problems? Yeah, right? Which is why it's got like a 1 for health. Because like you could have some issues if you ate a lot of it. Okay. So that's what I've got on this slide right here. In the corner here, it tells you about the health hazard. And it's basically a 1 to 4 scale. If it's like deadly, it's a 4. Be very careful with this material. If there's like no risk at all, it's a 0. So salt is like slightly hazardous. If you like just ate salt every day for a week, yeah, we'd have some problems. Right? Red, makes sense that red is for fire hazard. Basically what it's discussing is what's called a flash point. A flash point, if you've never heard of this before, is kind of like the temperature at which things can like spontaneously just start to like burst into flames. There are some things that if it gets too hot, they will auto-ignite. And so basically there's some things that just won't burn at all. There's other things that can actually just start combusting on fire, right? If it just gets hot enough, it will actually heat up. We don't even need a flame to get it going. Okay? So we need to be careful about those ones there. Instability basically is about whether or not it will blow up. So like 4, it could detonate. 3, if you drop it and shock it, could it detonate? If you heat it, is it unstable or is it like completely safe? Okay. And then this white category, there may be like a letter in there to just describe a couple of things, whether or not it oxidizes as an acid, is corrosive, or like never use water on it. There's some chemicals you should never add water to. They're very dangerous. So anyways, this is kind of our final safety symbol, where it just kind of gives you like a 4-box sort of thing here, and you're just looking for low numbers. If it's like a 001, we're good. If it's like a 331, be careful. I had a chemical that was in the back of my lab back at FP Walsh, where I believe it was like a 331. And like I was always very careful around that one because like not only could it combust, but like it was just extremely dangerous, right? So it gave me a warning as soon as I picked it up, just so that I instinctively knew, be careful with this. Okay. And I believe that's all I got. So let's do a quick recap, and then I'm actually going to give you guys a little bit of free time to work on whatever you want. But let's do a quick recap of the day. We need to know safety stuff. Okay. Really, there's 4 main safety things you guys need to know. I think 4 we can break it up into. Okay. Safety thing number 1, you need to know the symbol of like the shape. Red octagon very dangerous. Orange diamond, kind of dangerous. Yellow triangle, be careful. Okay. Usually these are found on like household products, like bleach or hairspray. Anybody have like hairspray? Look for this symbol on there. You'll probably see an explosive symbol on it, but probably not toxic, because that'd be bad, right? Corrosive would be on, say, like a bottle of bleach. Okay. That's one thing you should know. WHMIS, you should know all these new symbols in here. And again, they're pictograms. They're meant to be designed like road signs, so that like if someone came over from Australia or from Germany and like they looked at the picture, they could hopefully get a general idea of like, oh look, there's a dying fish here. Okay, bad for the environment. Or oh, there's a skull and crossbones. Don't eat it, right? Like they're hopefully fairly self-explanatory. I just need you to be able to memorize the picture to the words. If you can do that, you're good. If you don't fully know what some of them mean, we can talk more later. Okay, so that's 2. 3, you need to know what a material safety data sheet is, or from now on, we just call them safety data sheets. You just need to know that these are sheets that have info on them that tell you what to do in case. And they're long. I'll show you an example if you really want. This was like the first page of 1 out of like 8 pages. And it's got all these sections that just tell you stuff. Last thing, there's these symbols that go with the safety data sheets that basically break it up into numbers from 0 to 4, 4 different colors. Basically, if it's got a small number, it's safe. If it's got a bigger number, be more careful. Questions? Okay. I'm going to pause the recording, and then I'll give you some instructions.